Hi, hello, welcome back to our channel Chemistry with RK. Firstly, I would like to request, if you're new to the channel, please do subscribe and then don't forget to click on the bell icon to get the regular updates. In my previous video, I have discussed about the types of complexes based upon the types of ligands. If only all the ligands we have only one type, then they are called as homoleptic, and then if we have more than one type of ligands, we say them as heteroleptic complexes. So in the today's video, I am going to talk about some more types of complexes based upon some particular criteria. So let's start our video. Next let's see the classification of complex compounds based upon the number of metal atoms present in the complex. If we have only one particular metal present in the complex, then such complexes are called as mononuclear complexes. If we have more than one particular metal atom in the complex compound, those particular complexes are going to be called as polynuclear complexes. Anyway, the mononuclear complexes are further classified into three types. They are positive complex, negative complex and neutral complex, that we are going to see soon. Okay, so firstly let us understand what are mononuclear complexes. As I told you just now, the complexes which contains or which has only one particular metal. So if you can see here, this is actually a complex compound where you see only one iron atom. In the similar way, in the other example also, we can see inside the coordination sphere we have only one zinc atom, so the one zinc metal atom. So even if you take the other example, copper, we have inside the coordination sphere we have only one copper atom. So in all these three complexes, we are going to see only one particular metal atom inside the sphere. So we are going to call them as mononuclear complexes. Hope it is clear, no doubts, right? Yeah. And then next the other types of complexes are polynuclear complexes. And now, what are polynuclear complexes? The complexes in which more than one metal are present in the coordination sphere, that is in the complex compound. Yes, if you see the first example I have taken here, dicobalt octacarbonyl complex actually. This is called as dicobalt octacarbonyl, CO. I told you in the previous video that is CO, that is generally called as carbon monoxide. But when it comes to the complex compounds, we call that particular carbon monoxide as carbonyl ligand. Okay, yeah. So this is going to be dicobalt octacarbonyl complex. Generally, it is a neutral complex, that we will understand it in the coming few minutes. Okay, and now this is actually polynuclear. Why? Because we have two cobalt atoms, more than one metal atom inside the coordination sphere, then we can call them as polynuclear complexes. Similarly, we have dimanganese decacarbonyl complex. Actually, all these three examples I have taken, particularly they are called as metal carbonyls. We are going to understand about these metal carbonyls in the end of the chapter. We have a separate subtopic called as metal carbonyls, where in general in competitive exams they are going to focus more on this metal carbonyls, bond orders and bond lengths and all. We will see. We'll see in the coming videos. But meanwhile, yes, I have taken here it is di-iron, okay, di-iron decacarbonyl again. So what is the difference you see among this mononuclear and polynuclear complexes? Hopefully, I hope you have understood that. So if you have only one particular metal atom in the coordination sphere, then they are going to called as mononuclear. If we have more than one metal atom, then they are going to called as polynuclear complexes. So let me give you a question here. You have to define what type of complex this is going to be. Is this complex a mononuclear complex or it is going to be a polynuclear complex? That is the question I am giving to you. So here you can see two cobalts. So generally you say it is polynuclear. So it is not going to be the polynuclear complexes. This is going to be a mononuclear complexes. Why, sir? Because if you see inside the coordination sphere, whether you take this particular coordination sphere or this particular coordination sphere, inside the coordination sphere you can see only of one particular cobalt atom. So obviously this is going to be the mononuclear complex. Hope it is clear. So actually yes, this type of complexes do exist. So they are actually called, they can able to exhibit a coordination isomerism which we are going to see in the coming videos. Okay, so we have a separate subtopic called as isomerism in coordination complexes. There we are going to see this type of complexes do exist, and then they are going to show coordination isomerism. Hope it is clear. So hope everyone understood that why this particular example is a mononuclear complexes, why not a polynuclear complexes. So we need to observe inside the coordination sphere, if we have more than one metal, then it is going to be polynuclear. But here you see only one cobalt atom in any of the coordination sphere. Hope it is clear. You please try to take the screenshot of this, and then next we are going to define the classification of mononuclear complexes, as there are actually three types: positive complex, negative complex, and then neutral complex. Yes, we are going to see on what basis they are going to classify into positive, negative, and neutral complexes. Yeah, next let's see the types of mononuclear complexes. They are actually classified into three more types, positive complexes, negative complexes, and neutral complexes. So the first one, let me just take the positive complexes. So what are actually positive complexes mean? Okay, the complexes in which the coordination sphere is having a positive charge. Very important. So if the coordination sphere is having a positive charge, then we can call that particular type of complexes are positive complexes. Okay, so if you see, yes, this is the coordination sphere having a +2 charge, which is a positive charge. Yes, it is, this particular complex is a positive complex. And then similarly CONH3 taken 6 + 3. So you see on the coordination sphere a positive charge. So this particular complex is also a positive complex. So positive complex, or we can also call them as cationic complexes. Positive complexes, we can also call them as cationic complexes. Yeah, they may ask you which of the following is a positive complex, or which of the following is a anionic complex or a cationic complex. Such type of questions are frequently asked in the different competitive exams. And now if you see this one, okay, if they give directly like this, then it is very easy to identify whether it is a positive or negative or any type of complex it is. But in case they will not give this type of representation, they are going to give us CONH3 taken 6 Cl3. Yeah, and now even if we get this type of complex compound, this is actually the complete representation of the complex, where we need to go for its corresponding dissociation. So what happens if this complex dissociates? Yeah, it is going to give a CONH3 taken 6. Actually, before going to the complex charge, you just observe the counter ion charge. So we know the counter ions are chlorines, that is 3 chlorides we are going to get. So 3 Cl minus we get. So if we are getting 3 negative charges, to balance that, the coordination sphere must take the +3 charge. Hope you understood how to do this. Okay, I am going to give further. So if they give this type of representation, then we must be able to know its dissociation to call or to classify them as positive or negative or neutral ligands, neutral complex, sorry. Okay, and then we may be given this type of complex also. You observe carefully. So it is going to give Cl. Okay. And now if you look at this, we are going to get AgNH3 taken twice, and then we have only one Cl that is going to take minus charge. For that we need to take +1 charge on the complex sphere. Hope it is clear. So this is how we give the charges on the coordination sphere, so that it is easy to classify them. And now let me take some other example also. PTEN taken 3, that is going to be Br4. And now if you dissociate this, what type of ions we are going to get? PTEN taken thrice, and then we have actually 4 bromines, so we are going to get 4 bromide ions. And now total negative charge is -4, 4 into -1, -4. To balance that, this complex must be having +4. Hope it is clear. Yeah, next negative complexes. These complexes are quite opposite to the positive complexes. There we have seen the coordination sphere having a positive charge. Here we are going to see the complexes in which the coordination sphere having the negative charge. Such complexes are called as negative complexes, or they are also called as anionic complexes. So yes, if you see the 3 examples I have selected here, they are having negative charges on the coordination spheres. Hope Hope it is clear. So hence they can be called as negative complexes. Directly if we have such complexes in the given options, then we can easily identify whether they are anionic species or anionic negative complexes or anionic complexes. But if they give the, what do you say, that the complete representation, that is K4 Fe, suppose let's say we have CN6, and now you have to go with the dissociation where the counter ion is K, that is potassium present in first A group. First A group metals will have +1 charge. So we have 3 potassiums, each potassium has +1 charge. Totally we have +3 charge. To balance that +3 charge, the complex sphere is going to have -3 charge. Hope it is clear. And then we can also take here LiAlH4, lithium aluminium hydride we say. So we know lithium is present in first A, so it is going to have a +1 charge. To balance that, this AlH4 is going to have a -1 charge. Hope it is clear. And then we can also take what is that, K2HgI4, which is called as a Nessler's reagent, very famous reagent it is. Yeah, we are going to have 2 K plus ions, and then we are going to have HgI4 -2. So if they give directly such ions, it is very easy to identify them with, or classify them into anionic complexes or negative complexes. But if they give this type of representation, we must be able to go with respect to their dissociation, and then we can classify them as the negative complexes. Hope it is clear. Yes, will you please try to take the screenshot, and then we will complete the neutral complexes as well. Yeah, next let's see the neutral complexes. So here this is quite opposite to the previous two, positive and negative complex. Positive complexes which have positive charge on the coordination sphere, negative complex which have negative charge on the coordination sphere. Neutral complexes will not have any charge on the coordination sphere. In fact, they are not going to undergo any further dissociation also. So if you look at this NiCO4, this NiCO4 complex is not having any counter ions. When we don't have a counter ion, so that particular complex is not going to undergo any dissociation. Hope it is clear. So this particular complex, yes, we have seen in the starting, that is actually CO2CO8, that is dicobalt octacarbonyl complex, which I have taken it in the polynuclear complexes. Yes, this particular complex can also be considered as a neutral complex, because this coordination sphere has no charge. It is not going to have any positive or any negative, but in fact it is going to have a zero charge, means no charge on the complex sphere. They are going to call it as neutral complexes. Hope it is clear. Yes, with this I am going to end up the video, and then in the coming video we are going to see the classification of ligands, which is very much important to name the coordination complexes.